Hello everybody, today we will be learning about simple machines, pulleys. Okay, so firstly some introduction. Hello, my name is Ada Ishaba. I am a student at University of Toronto Scarborough and I am studying sciences just like you. Today I'll be teaching you about pulleys and show you how to make one on your own. So today's agenda is first we will have our lesson on pulleys. We will learn what a pulley is, how they work, and some pulleys in action, and then we will make a pulley on our own, basically by making a flagpole. Flagpoles use pulleys, so we will be learning how to make a pulley. Okay, pulleys. So what is a pulley? A pulley is a simple machine. What is a simple machine? It is a type of mechanical device that makes the direction and the amount of force change. It consists of a wheel that can spin freely on an axle and a rope which passes through it. We can see it over here on the right side of the screen. There's a pulley. Okay, so how do pulleys work? By attaching a heavy load at one end of the rope, we can pull the other end of the rope to lift the weight easily. The load is either attached to the pulley, movable pulley, or the rope, fixed pulley. You can see over here, it's a fixed pulley over here. The load is actually attached to the rope and there's a wheel and the rope is passing over the wheel. Okay, some examples. So here's a fixed pulley, a weight is attached to the rope and the rope is passing over the wheel to the other side and then we pull it from the other side. Okay. So here's a man doing the same thing. He's trying to lift up a heavy weight and it makes it easier for him to lift it up using a pulley than by using his bare hands. Okay, mechanical advantage of pulleys. Mechanical advantage. Simple machines amplify the force that we are applying so that we can easily lift the weight. The pulley causes the force we apply to be large enough to lift the weight. Work done. Work done is force over a distance. So it's basically energy. Work done is energy and the formula of work done is force into distance. When we apply less force to a system, we need more distance. When there is less distance, we need more force. This is because energy needs to be conserved. That means the energy has to be the same. Okay, work done by pulleys. The force is applied by us as we pull the rope. The distance moved by the load is multiplied with that force. If we apply less force, the distance has to be more and vice versa. This allows us to lift the weight with less force from us, but the same energy due to the longer distance. So basically, if this is the load, if this is the load and the pulley is over here and there's a rope that is pulling the pulley, so the distance from the starting point of the load, that is basically the ground, and the final point or the point where the load is right now, the distance between these 2 points is basically the distance that we take for finding out work done by the pulley. Okay, so pulleys in action. Cranes use pulleys to help us lift weight, and those weights are pretty heavy, and cranes are used during constructions, right? We pull the string that is on the pulley to lift the flag up or bring the flag down. So guess what we were talking about? We were talking about flag poles. So we basically use pulleys over there as well. And we're going to learn about it and have a practical example of how that works. Okay, so let's reflect. Number 1, what is a pulley? Number 2, what is the mechanical advantage of pulleys? How do they affect work done? 3, name some places where we use pulleys. So take a moment, reflect on these questions. Okay, now time to apply. Let's use what we learned about pulleys in making a flagpole. We will be creating devices to lift flags. Okay, so here's a material list. Take a moment, pause the video and gather all the materials that are required. And here are the safety rules. Please go over the safety rules and then we should begin. Okay, so we are gonna make a fixed pulley. So the procedures are over here. So if you guys don't find a dowel, then you can find a paint stick. If you can find a paint stick, that's good enough. And I'm gonna use this. It's an old wooden scale. We take clay. over here, and then we attach it to the paint stick or dowel, whatever you have, whatever works best for you. Whatever is handy will work. So it's gonna be like this. So this is to make the police stand. Okay. Okay, then we take 2 binder clips, one at the top and one at the bottom. And then we bend the arms of the 2 clips so that they stick out to the sides. Thread the string through the 2 clips. If you don't find a string, use a thread, whatever works for you. Okay. So here we go. And then tie a knot so that we can make a loop. So here we have got our loop. Okay. This is how it should look like. Okay, now decorate your flags. For the purpose of time, I did mine. I didn't decorate them, but like you guys should decorate them. Take a brief moment and decorate your flags. So after that, cut 2 diagonal slits on the left side of the flag. And then slide the thread through it. Okay, so one at the bottom and one at the top. Okay. Like this. Okay, slide the string through the slits to attach your flag. Pull, so here is our flag. And then you guys should make this stand on the table, but like to show you guys, I'm gonna do it here. Okay, so now pull the string to lift the flag. Okay. Okay. For the second one, we need push pins. So do the same thing. Repeat step 1. And for this, skip steps 2, 3, 4 and use 2 push pins instead. Leave gap between the wood and the end of the pin. So we're gonna do it like this. Here's the push pin. Here's the push pin. And we are gonna force it through. Please make sure that you guys don't hurt yourself. Please make sure you guys are careful because these are sharp. Use a rubber behind your stick and then push the pins through so that you guys don't get hurt. Okay, so now do this. Repeat steps 5, 6, 7, 8, 9. Make a loop using a thread or a string, whatever works best. And then the same thing with another flag. And I'll just slide it through. Like this. And now we will try to pull it. Okay, and we're done. So let's consolidate. 1, were you able to move the flag up and down for both the flagpoles? 2, which flagpole was better? 3, what could have led one of the flagpoles to be better than the other? So think about these and find out the answers. Okay, so thank you for engaging. If you have any questions or comments, we will love to hear from you. Email StartScience or visit our page. Bye.